This video is on CNC lathe program turning an ID groove. Our grooving tool is 100 thousandths wide, which just happens to match the 100 thousandths groove right here on the inside of this part that we're going to cut. So our tool number is tool 304, tool 3 in the turret, and tool offset 4. G0 rapid, G20 verify inch coordinate position, G40 tool nose compensation cancel, G80 canned cycle cancel, and G99 feed per revolution. So that puts our machine in feeds per revolution. G50 is maxes the spindle out at 1500 RPMs. G96 gives us a constant surface speed of 200. M3 turns the chuck on and forward. G54 is the offset we're using this time. X0, Z of 0.1. So if this is in the chuck, which it would be for this application, then X0, Z.1 would be, X0 would be dead center in this bore, and then Z of 0.1 would be 100 thousandths from this face. Good safe starting position so you can look and see if anything's wrong. Then we're going to do a G01, Z of negative 0.2, because we touched our tool off right here, and we have 100 thousandths here and another 100 here. So if we come back here, our little tool will cut this out completely. And the reason I did a feed move is because I didn't want to go flying in the bore and rapid. You could once you verify your program. And I did a feed rate of 3 thousandths. So here's where we start cutting. So I have the inside dimension of this hole is an inch. So I went in an inch. That way you can verify everything looks right. I went in an inch 50 thousandths, so I took 50 thousandths out. Then I backed out 50 thousandths so that the chip could break off. I go in 1.1 in X, which is another 50 thousandths, so the chip could break off. I'm basically pecking like a woodpecker. In 50, out 50, and then we finish at X of 1.2 because that's what our print says. Then we do a G0, X of 0, so we came straight back out this way to the center, and then a Z of 5 inches, and a G28 to send the machine home.